Hi everyone, I'm Jamie Bullock. I'm the Director of the Integra Lab research group here at the Conservatoire. I'm going to present to you a piece of research that we've been working on for the past nearly 12 months now, which ties in quite well with Ian's talk at the beginning of the day, if you're here for that, and deals with virtual manipulation of sounds within a virtual environment. But before I sort of go into that system, I'm just going to give you a little bit of background on where we've come from with it and the problems that we're trying to solve in doing so. So I guess before that, most of our work as a research group, so from about 2009 onwards, revolved around a quite large-scale European-funded project called the Integra project. And this was a culture-funded project. And the culture, I don't know how much you know about the intricacies of European funding, but the culture fund is really geared towards funding cultural outputs, so sort of big performances, operas, musical exchange around Europe and that sort of thing. It's not as such a research fund. But the project that was set up here, the idea of it was that we would get together new music ensembles from around Europe who would be typically performing musical repertoire for the last 50 years or new commissions, and composers of new music. And then we would, the goal of the project was to say, well, these two groups of people, these two groups of stakeholders, the performers of new music and the composers of new music, need tools in order to work with technology, interactive technology, to work with music technology. And I suppose the premise of the project was that existing environments, those typically used in what would be called live electronics performance, so that's kind of, for want of a better phrase, kind of classical music but with live audio processing, live effects and so on, live transformations on sound, that existing tools for doing that weren't sufficient in terms of their usability and user interface design. So, I mean, you know, a very common situation which we would have had here, for example, as a public-facing arts organisation who puts on these types of concerts, is somebody will decide that we're going to perform a piece at work, could be a new one, could be an old one. And then the score will be quite straightforward. We'll get the score sent from the publisher, and that will get given to the performers to play. But along with the score will be something that's got the electronics on it. And if you're kind of lucky, it might be a CD-ROM with a max patch on, which we've then got to kind of look at and find out if it works or not on latest computers. But I mean, assuming that everything does actually work, in environments such as Max, which is more Max MSP, which is the typical environment that's used for these types of pieces, is really an incredibly complicated and complex environment. I mean, Max sets itself out as, well, if you go to the Cycling 74 website and look at the front page of it, it doesn't say Max MSP, a new tool for the composition and performance of live electronic music. The remit of the software is much, much wider than that. It views itself as a sort of generic programming language for artists, but even maybe beyond that, to kind of rapidly prototype interactive systems. So the kind of challenge sort of set out by Integra really was to combine these new music ensembles and composers, these musicians, with the expectation of a usable environment, with research groups and research centres from across Europe who would look at the problem of usability and user experience in these kinds of tools and try and produce a new environment which attempted to solve some of those problems. And so, as the scientific working group of the project, we were given sort of 9 to 12 months to come up with something and then give to the artists to go away and use. And the results of that were the Integra Lab software. And we examined very carefully musical workflows and so on, and we worked with designers. We took a very design-oriented, design-led approach to the software. And it's worked pretty well. I mean, it had over 25,000 downloads since it was first released, I think, in 2011, and it's got some fairly big. It's mainly been used in education institutions, so some fairly big sort of higher education institutions using it, Paris Conservatoire, University of Montreal and others, and it's kind of got a good user base around it. But for us, as a sort of music interaction research group, there's sort of level of dissatisfaction with it, and I suppose we're always trying to push things and make things better. And we feel that there's, this is our website by the way, integralab.org, if you want to check out the software. Whilst it does make performing and composing music with live electronics an order of magnitude easier than it is with something like Max. I mean, you can have a working setup with some delays, some harmonisers, various forms of processing within less than a minute of opening the application. So it does offer a massive paradigm shift in usability. We really felt that the fundamentals of the interface really boiled down to things that were already being done elsewhere and were problematic in themselves. So that it provides this kind of modular module view, where you can patch different modules together that do different things, and then it's got controls associated with those modules, and these are much higher level than Max or PD objects, but nonetheless, the musician or the performer or the composer is still interacting with one slider for a low-pass filter which says resonance or frequency on it, or a delay, a digital delay, which says delay time and feedback, for example. And things like delay time and feedback aren't necessarily meaningful to musicians who spend 20 years practicing the violin. So this follow-up project that we've been working on now seeks to kind of look at things in a completely new way and kind of sort of throw out of the window, in a sense, the whole idea of interacting with these low-level parameters. And so the concept of it basically is that you have, rather than thinking of sound as something that happens inside, or sound processing, or sound transformation, or sound manipulation that happens inside the computer, and you put a set of controls on it, maybe hardware controls, to interface with these individual things, that you think of the sound as something that has a physical presence, and you have a sort of embodied approach to your interaction with it. So it looks at the idea that you could have, conceptually, a sound in mid-air in front of you that you can physically touch, you can move around in space, and you do various operations on, for example, stretch or compress or shake, or do things that you might think of doing or imagining doing with a physical everyday object. So that's the kind of broad idea of it. This work's funded by the AHRC Digital Transformation Small Grant Scheme, and the idea of that scheme is to have a big idea like that, but sort of fund a small sort of implementation of it. So what we've started off with is, rather than to try and do everything and completely create an incredible system that does everything that Integra Lab does, but lets you do it in a sort of touch-free, what was the word you used here? Freehand interaction sense. We've just taken what we thought was the most obvious aspect of audio manipulation or sound transformation, the one that mapped most readily onto this kind of embodied approach, which is sound spatialization or sound positioning within space. And so we set out to devise a system where you could grab a sound, place it within a space, and then move it around within that space. That was the kind of idea. So what I'm going to do now is I'm going to try and demo what we have. Well, I'll show you the system, and I'll talk about the elements of it, and then I'll try and do a sort of like demo of it if I can, rather ambitiously, with the fallback of having a video to play in case it doesn't work. Okay, that should be long enough. So this is the software's, for those who are interested in this kind of thing, the software is implemented in Unity, using the Microsoft Kinect as a motion capture device. These were completely pragmatic decisions in terms of what we used. The project is a partnership with Glasgow School of Arts Digital Design Studios, and they have strong expertise in Unity and already using Microsoft Kinect. So because we had a short amount of time to develop it, we didn't want to spend months evaluating what the best sensor was. We wanted to hit the ground running. Now, this is the kind of virtual space that you place the sound into, and something I'd like to get input from all of you on and discussion about, really, is that actually, even though we're trying to move into a situation where we've got a visualisation of the sound here, and I think it's here in the room, there's already a kind of metaphor going on here. There's already some kind of mapping. So, well, I'll give you see if I can get it working in it, rather than talking about it more. See if I can get it to recognise my hand. Yeah, maybe it's a bit dark for it. While the lights are coming, there we go. It's a bit. Sorry. It's all right. Yeah. Well, that's maybe I need to stand up to the side or something. There we go. Perfect. Okay, so that little sort of thing that looks like a Mac OS 9 icon is an avatar of my hand, and if I go to this palette of sounds to the right, I can grab one there, and now I'm holding that sound in my hand, and I can now move it and position it within the space. And if I let go and release it, playback starts. Now if the sound is already there, lost my avatar again. There we go, it's a little bit closer. Okay, so I can grab as many. These could be anything, by the way. At the moment, they're audio files, but they could equally be live audio sources. It's not. Well, you can see here immediately some of the user experience problems that we've identified during the project. Okay, so we've got two sounds there now, and I should be able to grab an existing one, and then this links very nicely to Ian's presentation earlier, because I'm trying to grab that shaker there, and then you can see I've got a sphere that's hanging over it, and it's actually very difficult for me to get that accurately positioned. Okay, I'm not going to spend too long on that, but you can get the idea. Okay, I'll put one more in. And this is binaural. I mean, you're not getting binaural playback, obviously, on the speakers, but it is binaural, using binaural spatialisation. So if you're wearing headphones with the system, you can actually place the sound behind your head. So I'm not going to do too much more demo there, but just to, I mean, it's been a very interesting thing to work on, and this is actually a system. This is where the system was in September last year. We've added a few more elements to it there. So you can, for example, with your left hand, draw a trajectory within the space, and we've got a Vimeo video online which shows us doing this. You can sort of draw a trajectory in 3 dimensions, and you can kind of place the sound on that trajectory, and it will kind of roll along it, which is good. And you can also, might be able to demo this, but if I hold up my other hand, it should give me a volume control. Probably only if I grab something actually. Never mind. It's anyway now. But you know, some of the interesting problems here. I mean, we did some usability tests on this with a number of users and user experience tests. And we asked users to perform a number of tasks on Logic Audio's binaural panel and with our system. We asked them to do the same things with those. And I mean, we're going to be publishing on this soon, so I mean, I'll obviously post about that on our Twitter and so on. But the kind of key findings of it were that people were able to very, very quickly, by looking at this and being standing in front of the sensor, know what they were supposed to be doing. But in fact, because of implementation issues with the sensor and so on, and the kinds of stuff you've seen, lighting levels, proximity, and all the sensitivities of it, that it actually took them longer to do. They knew what they're supposed to be doing, so we felt that the design was solid. We thought from a design point of view, we're doing something interesting here, and people responded well to it. From an implementation point of view, we found it very problematic. So that's really the next step for us, to sort of look at solving that and other sensors or other approaches we might do to do that. And obviously welcome all of your expertise and feedback on that. Okay, thank you.